Good morning, Jonathan. How are you?
Very good. Thank you, Ethan.
Yeah. Today we'll discuss about visual programming and coding, and you are the expert in Vectorworks, and you're the main guy.
Thank you.
Can you
Um,
tell me about your experience for that visual programming and coding, and how did you do that?
yeah, sure. I thought maybe what we should talk about is the need for programming in architecture. I was watching a YouTube video the other day and somebody was drawing in AutoCAD and they needed to create a series of foundation details. So they actually scripted an AI generator, Claude they used, to actually generate the code so that they could then have an Excel spreadsheet. They could type in the details in the Excel spreadsheet, and this would then generate the foundation plan, sorry, the foundation details with the cover, so it would give the right cover to the concrete between the concrete and the reinforcing. It would draw the reinforcing. It would draw the foundation detail. And you start to think about this and you start to think, wait a minute, is there a need for us to teach coding to students? And it reminded me of our conversation with Max last year, where Max clearly said that he thinks it's a great idea to teach some form of code development or some sort of coding to our architectural students. We haven't got time to do it, but it would teach them that this is a changing world, that things like Claude will actually write computer programs for you to take over some of that heavy lifting work. So that's the first thing, is that yes, we might need to teach some coding. Now, the important thing about teaching coding isn't teaching the code itself. It's teaching a way of thinking about the problem. Because when you teach computer coding, you start to break down the problem into a series of repeatable steps. And that's, if you can't get those repeatable steps, the program is really difficult. So Vectorworks has this visual program language called Marionette. And the idea behind the visual language is that you don't actually have to know the code to make it do things. So the idea would be, I want to make a timber bollard. Well, what's it made out of? It's got a first part is there's an extrusion part. Then there's another little bit on top, and there's another little bit on top of that. And what you would want to do with once you've learned how to do some coding, is the first thing you do is you break that into some simple chunks. Oh, so it's a rectangle and we extrude it. Is it a rectangle or is it a circle? These are decisions you'd make along the way. So you would take the complex problem of that object and you would break it down into chunks, and you'd say, okay, I need a rectangle. How big is the rectangle? I need to input some information. So I need to have an input that takes the input, then it builds this thing, then it does that thing. And the visual language makes it easy because you don't have to know what the code is for extrusion. There's just a little block and you go, okay, so you'd have an input field. So you got these little blocks, input, and then you click on the input and you drag the wire to the input for the next part. And you take the output of that one and you connect the wire to the input of the next part. And you then break up your problem into a series of blocks, which you can then join together with wires, and you don't need to do any coding. But if you didn't understand what I call algorithmic language, that is the language of an algorithm, if you don't understand how that works, then you start saying, okay, I need a rectangle. And then you realize, oh, but I need the size of it. So you then start you end up being back to front. And so you might start with the end and you can gradually break it up that way. But it's really important that the student learns the structure, that it's not just like writing an assessment where you've had some of these assessments, Ethan, where they start and they just start putting information down without any logical structure to it. And I guess that's the word I was looking for, logical structure. The visual programming doesn't remove the need for a logical structure, but it removes the need to know the code behind it. So you still have to think in a logical way. Now, Vectorworks isn't the only one. So there's things, I think, I'm trying to remember the other ones. There's lots of programs that have got this visual language, which makes it really easy. I think Bamboo, Grasshopper, Rhino, some of these programs have got the same visual thing built in, and you can build objects by putting these blocks together, and then you can take an input. One of the classic things is that for some of the modeling, people are taking a polygon and making a building out of it. And by changing the shape of the polygon, the building changes completely. By changing some of the inputs, like how many stories is this building, you can completely rebuild the building in seconds, where it would take you hours to do it if it wasn't for this visual programming. Unfortunately, with the architectural technology course, there's not enough time to teach visual programming. I think they teach it at Victoria, at the architectural school. They teach some of that coding in the visual language. Yeah, if you look at what AI can do for our profession, you start to think, where does the architectural technologist come in? Where does the architect come into this? Are we still going to be doing detailing? Are we still going to be doing the manual drafting? Or is AI going to take over some of that, and it's our job to know whether it's doing the right thing?
Yeah. What are the practical benefits and limitations of visual scripting versus traditional text-based coding in design context?
Let's start with the benefits first. The benefits are that you don't have to know how to do text-based coding. Now, I can write some simple vector script, some simple Vectorworks scripts to build things, but I had to learn how to do that text coding, and it meant quite a lot of thought. It was quite a lot of work for me to learn how to do that, because I'm not traditionally a computer programmer. So the big benefit is that even people who've got no understanding of the text coding can use these visual blocks to build repeatable objects. So that's the first thing, is there's a huge benefit there. Now, what's the limitation? The limitation is that you can only build the blocks you've been given. So if you wanted to build something that Vectorworks hasn't already, let's not use Vectorworks, but if you were using another program and you got these visual blocks, what happens when you don't have the block you want? You're stuck because you can't make it do it. Now, all of these visual scripting systems have got the ability for you to create your own blocks. So if you did understand the scripting, language, you could actually build your own block and get around it that way. Now, there are lots of people that have done this. There are forums around that have done this. And those people will actually share their blocks with you if you join that forum. I know in Vectorworks, there's a forum, and people have shared their Marionette blocks that will actually expand the use of Vectorworks. But think of it this way. Let's say, for example, we want to have more information about our building. So we've got an object in CAD programs, which is normally like a sun. It gives a location of your building. You can tell it what city your building is in. So if you then said, okay, this object here is telling my design where I am in the world, latitude, longitude, time of the day, we can use that to do sun analysis, which is easy. It's all built into the programs. But could you use that object to actually then build a visual script that would actually take the location of your building, go and look up meteorological data and create a windrows for you, which would be quite cool. Because you could then start to say to that script, give me the information I need as a general thing. So what's my average wind? But you could also start to give it a little bit more data and start saying, so in the winter, where does the sun come from? In the summer, where does the sun come from? What's the strength of the wind? What's the strength of the wind in the winter? How many days of rain should I be expecting? And what's the intensity of that rain? So I can design my gutters. So your visual script you could put your heliodon or your sun object in. It would know where you are in the world. It would then go off and find some information for you and report back. Now, the next thing would be you then make a digital twin. Not only does the digital twin find out where your building is, but it then starts to look, this morning, here's your report. The building that you've designed, this is the likely weather that it's going to have today. Next week, we're expecting stronger winds. So do you need to go to check the building to make sure that everything is correct? Or do we put sensors on the building that can then start to tell us whether the building needs maintenance, whether the drains are blocked? We could even have things like drones to fly over the building to measure whether the drains need cleaning. I don't know the Mount Eden Stadium, in order to spray the water, in order to spray lichen and mold, they fly a drone and they spray the building in the old days, they used to send a guy up on a ladder and spray, and it was very expensive. Now they can send a drone up to spray in no time. There are Chinese farmers using drones to deliver fertilizer.
Yes.
So we're heading to this area. So that would be my answer for the scripting. There are huge practical benefits for this by extending what our computer programs are able to do, because we can make them do the job we want by joining those visual nodes together. And if the node doesn't exist, then you can write it. Now, most of them are written using a language called Python, which is an international language. It's now becoming a really important language.
And object-oriented.
Yeah, so Python's an object-oriented program language. So C++, people can move from one to the other because it uses object-oriented program language. So you can write your own. Now, what if you're limited in your ability to write Python? Hey, Google, can you write this for me? And so you can actually say, I'm using, Rhino, or I'm using Grasshopper, and I need to write the script, and it can then write it in that format. I've used it with Vectorworks, and I've said, I'm using Vectorworks. Can you write a script for me? Now, they're not always perfect, but they do a pretty good job of getting you started. They're like a junior, and they'll do a pretty good job, like Max said in that previous podcast. So that would be my understanding. Is coding a core technical skill for technologists? I think that this is one area that we are going to move into, that it is going to become inseparable from looking at the technical aspects of design and construction. We haven't spoken a lot in our podcast about digital twins lately, but my guess is that Python is going to become really important when you start to build your digital twin, because of the ability to go out and get information from the outside world. Python allows you to not keep that script inside your computer program, but to go outside and find stuff from the world and bring it in.
Okay. I think we should stop this week for this podcast. And we'll talk about Python with another topic.
Yeah, good point. All right. Thanks very much, Ethan. Sorry to go on.
It's all right.
Don't forget to hit the like button, to subscribe to us on Spotify so that you get updated every time we release another one.
Bye.